Welcome friends in the class of standard access list. Here I took three routers R1, R2, R3. The subnet between R1 and R2 is 10.1.12.0 and the subnet between R2 and R3 is 10.1.23.0. I took loopback 0 on all the routers. The IP address of loopback 0 on R1 is 1.1.1.1, on R2 is 2.2.2.2 and on R3 3.3.3.3. For basic reachability I use OSPF area 0. Here you can check show IP route OSPF. We have reachability towards loopbacks of both the routers. From R3 also show IP route OSPF. Here we can ping right. So our our goal is to block R1 to ping R3. For that we will use standard access list on R2. We'll create an access list 10. We need to deny host. What I want to deny 10.1.12.1. Then we can permit access list 10 permit anything else. Then we go to the interface and type IP access group 10 out, right? Show access list 10. Here is deny 10.1.12.1, right? So now if you go on R1, last time you can see there, here we can ping 3.3.3.3, but now if I try to ping, it says it's unreachable, right? Because now it's hitting on this access list. See, it's deny, so it's match, right? Again, if you ping with the source, once you ping with the source, then there is the destination is 3.3.3.3 and the source is loopback 0. In this case we are not using 10.1.12.1. that is the reason. If you again see the access list, see, now it's matching anything else, right? So through this way you can block some traffic if you want by the help of standard access list. The main drawback of standard access list, you only have the source information, so you need to put this access list near to destination. So the bandwidth between these links are unnecessarily used, right? Because we are putting them near the destination, right? Thanks. Welcome friends in the class of CCNA switching. Here we will discuss the topic DTP, which is dynamic trunking protocol. By the help of DTP protocol, a switch port can become a trunk port dynamically, right? So in this topology I took 23560 series switch and they are connected through the interface fast Ethernet 0/1. So right now if you check show interface trunk, there is no port which is trunk, right? Show interface fast Ethernet 0/1 switch port. It shows that right now currently the administratively mode is dynamic auto. That means it will not actively sending the DTP packet. That is the reason it's an access port right now. We can check same on switch 1. Here on switch 1, show interface fast Ethernet 0/1 switch port. Here also this is dynamic auto, and that's the reason it's static access. Means if two ports are in dynamic auto mode, they will not send any DTP packet. That is the reason they are still in access mode. So for changing that, let's suppose go to the configuration mode, interface fast Ethernet 0/1 switch port mode. Here you can see dynamic desirable. Once you type this command, that means this port will become the dynamic desirable port, so that it will actively send the DTP packet. Once it will actively send the DTP packet to become a trunk port, they can make the trunk neighborship. So if you check now, show interface fast Ethernet 0/1 switch port, see, the mode is dynamic desirable and the operational mode is now trunk. Show interface trunk command. You can see now the port F0/1 is a trunk port now, right? So there are two modes, one is dynamic desirable and one is dynamic auto. So if this port is dynamic desirable and this port is dynamic auto, they can make the trunk between them, because this particular port is actively sending the DTP packet, right? So by this way you can check and you can enable the DTP on your switch port. Thanks. Hello friends, welcome in the class of VTP, Basic VLAN Trunking Protocol Configuration. As you already know, the use of VTP is to reduce the administrator work for creating the VLAN in different switches. And here in VTP we have three modes. One is server mode, one is client mode, and one is transparent mode. Let's suppose my switch 0 is work as a VTP mode server and these two are clients, right? For making a switch as a server, we have to go to the switch and go to the configuration mode, type VTP mode server. Okay, because by default the switch is already in server mode, so it's showing that device mode already VTP server. Okay, let's suppose VTP domain cisco.com. okay, and then VTP password Cisco. Okay, now go to switch 1 and type VTP mode client VTP domain cisco.com. VTP password is Cisco. Switch 2 is also client. So what is the configuration? VTP mode client VTP domain cisco.com and VTP password is Cisco, right? So now because switch 0 is in server, so for checking purpose you need to type show VTP status. Here right now is VTP version 2 and the configuration revision number is 0 because till now you haven't add anything. If you can check show VLAN, I haven't created any VLAN yet. So if I create VLAN 10, let's suppose VLAN 20, let's suppose, and VLAN 30. So if I type the command show VTP status is 3 now because I have created 3 VLANs, so the revision number is 3. So go to the switch 1 and see show VLAN. These VLANs are automatically created here because we are using VTP. So in switch 2 also show VLAN, it's 3, right? So now on switch 1 if you type the command show VTP status, here the revision number should same, it's 3, right? And switch 2 also show VTP status is 3. Okay, now one more thing, in client mode you can't create any VLAN. Let's suppose you want to create VLAN 40. It says that VTP VLAN configuration not allowed when device is in client mode. So it's server responsibility to create all the VLANs and they will replicate through VTP in all other switches. So this is the basic configuration which you can, how you can configure VTP, and you can for verification purpose there's a command show VTP status. Okay, thanks for listening this video. Thank you. Hello friends, welcome in the class of VTP, Basic VLAN Trunking Protocol Configuration. As you already know, the use of VTP is to reduce the administrator work for creating the VLAN in different switches. And here in VTP we have three modes. One is server mode, one is client mode, and one is transparent mode. Let's suppose my switch 0 is work as a VTP mode server and these two are clients, right? For making a switch as a server, we have to go to the switch and go to the configuration mode, type VTP mode server. Okay, because by default the switch is already in server mode, so it's showing that device mode already VTP server. Okay, let's suppose VTP domain cisco.com. okay, and then VTP password Cisco. Okay, now go to switch 1 and type VTP mode client VTP domain cisco.com. VTP password is Cisco. Switch 2 is also client. So what is the configuration? VTP mode client VTP domain cisco.com and VTP password is Cisco, right? So now because switch 0 is in server, so for checking purpose, you need to type show VTP status. Here right now is VTP version 2 and the configuration revision number is 0 because till now you haven't add anything. If you can check show VLAN, I haven't created any VLAN yet. So if I create VLAN 10, let's suppose VLAN 20, let's suppose, and VLAN 30. So if I type the command show VTP status is 3 now because I have created 3 VLANs, so the revision number is 3. So go to the switch 1 and see show VLAN. These VLANs are automatically created here because we are using VTP. So in switch 2 also show VLAN, it's 3, right? So now on switch 1, if you type the command show VTP status, here the revision number should same, it's 3, right? And switch 2 also show VTP status is 3. Okay. Now one more thing, in client mode you can't create any VLAN. Let's suppose you want to create VLAN 40. It says that VTP VLAN configuration not allowed when device is in client mode. So it's server responsibility to create all the VLANs and they will replicate through VTP in all other switches. So this is the basic configuration which you can, how you can configure VTP, and you can for verification purpose there's a command show VTP status. Okay, thanks for listening this video. Thank you. Welcome friends in the class of CCNA switching port security. Here I took a switch 2960 series and the interface FA0/1 is connected to fast Ethernet 0/0 of the router. Here I'll assign the IP address to the VLAN 1 interface, which is 10.1.1.2, and the router interface, which is 10.1.1.1, and we have reachability, right? So now currently in the MAC address table, if you see, we have the MAC address of router 1 right here, right? Now I want to assign a port the port security feature here on this switch so that it can only learn a single MAC address, right? So for that we have to go to the interface fast Ethernet 0/1 switch port, mode access, switch port security, switch port security maximum 1, switch port security violation shutdown. So what does this mean? This means that if I learn more than one MAC address on this particular interface, which is fast Ethernet 0/1, then that particular port will be in down state, right? So let's ping it again. Now in my CAM entry I have a MAC address learn, right? Let's suppose I go into the router and change the MAC address of the interface. Let's suppose go to the interface fast Ethernet 0/0 MAC address. Let's suppose 000000000001. Once I change the MAC address, you can see here it will go into the down state, administratively down. See, operational mode is down. Show port security interface fast Ethernet 0/1. See, securely down because we have learned one new MAC address and the security violation is 1 now. So this is the basic example where you can align a port into the port security feature, and if more than one MAC address will learn, then that particular port will be go into the down state. Okay, thanks. Hi friends, welcome in the class of inter-VLAN routing. Here I took one switch which is connected through two different devices. We have two laptops and one router, right? So what I'll do, I'll create two VLANs and I'll assign these ports in different VLANs which are connected to our end systems. I've created VLAN 10 and I've created VLAN 20, right? Now the interface which is going to the laptop 0 is switch port mode access. Now VLAN 10 interface fast Ethernet 0/2 switch port mode access, switch port access VLAN 20, and then a port which is going towards the router is trunk, right? We have to make that port as a trunk port. Now what I'll do, I'll do the basic configuration on my laptop 0, which is the IP address. Let's suppose the IP address is 10.1.1.1. The gateway is 255.255.255.0. Now I'll go to the system laptop 1 and I'll assign the IP address 20.1.1.1. Now what happened if I'm trying to ping the system which is in different VLAN? I can't, because for that I need inter-VLAN routing, right? For that what I have to do, I have to go to the router and no shut the port first. Then we have to go to the sub interface. IP address is 10.1.1.10. And then we have to go to the interface. IP address is 20.1.1.10. So what I did here, I have created two logical sub interfaces, and I have assigned the subnet which I have given different laptop, right? Now I have to go to the laptop 0 and I have to give the default gateway, in this case which is 10.1.1.10. Same, I have to go to the laptop 1 and assign the default gateway which is 20.1.1.10, and I've tried to ping now. Let's suppose I ping my gateway, because for checking the reachability, first of all I have to reach to the gateway. Now I can try to ping to the another gateway. If I can reach. Now I can go to the another laptop IP address. I hope one request goes down and then it will come up, because that is for ARP request. Now you can see the result. So by this way you can provide the communication between two different laptops, right? Okay friends, here welcome in the class. Here I'll demonstrate you about the VLAN. Here we have two PC0 and PC1, and they are in the same subnet. So let's configure the PC0. Let's suppose the IP address of PC0 is 10.1.1.1 and the default subnet mask, and the IP address of PC1 is also in the same subnet, which is 10.1.1.2 with the same mask, right? So now if we go to the first switch, that is 3563 switch, and this is the interface which is fast Ethernet 0/1, and this is fast Ethernet 0/2. So what I'll do, I'll create a VLAN which is VLAN 10. First of all, you have to see by the help of command show VLAN how many VLANs you have. You have a VLAN 1 which is a default VLAN, right? And all the ports are right now the part of VLAN 1, right? So now I have to create VLAN 10, let's suppose, and these particular systems are part of admin department, and I have to type the command VLAN 10, then I have give them the name is admin, let's suppose. So now when you type the command show VLAN, you can see here a VLAN admin has been created, but there is no port yet assigned in this VLAN. So let's suppose I have to assign port number 0/1 in switch port mode access, switch port access VLAN 10. Now this particular port is part of VLAN 10, right? And this is the trunk port FA0/2. So once we will go to the FA0/2 switch port trunk encapsulation. So we have two types of encapsulation, either ISL and .1Q, but this switch is only supporting .1Q, so you can type .1Q and then switch port mode trunk. So by the help of this command you can make a port as a trunk port, right? So go to the switch number 1, same thing, enable config terminal VLAN 10 name admin, right? So once you type the command, you can see that you have already created a VLAN which is name admin, and then go to the interface fast Ethernet 0/1 switch port mode access, switch port access VLAN 10, and then go to the port number 2 switch port trunk encapsulation .1Q switch port mode trunk, right? So once you type the command show interface trunk, so you can see that this particular port FA0/2 is right now in trunk using encapsulation 802.1Q, and the mode is trunking, native VLAN is 1. We will discuss this, and right now the VLAN 1 and 10 is allowed, right? So this is the way you can create the VLANs. And now if you want to ping PC1 to PC2, you can see that we can ping. We have the reachability. Here you can see show MAC address table. Here you can see you have the MAC addresses for PC1. Let's suppose see this is the MAC address 000A41A8, and you can check here. So we have learned this through this port FA0/2, right? So this way you can check what are the MAC addresses you have. Let's suppose you go to switch 1, here show MAC address table. You have learned this MAC addresses on fast Ethernet 0/2 interfaces, right? Now go to PC1 and try to ping from here, right? So in this way you can check. Now you have two MAC addresses. You have all the MAC addresses now, right? So this is the way you can create the VLAN. VLAN is basically used to segregate your broadcast domain, right? By default, switch having one broadcast domain. So if you want to segregate the broadcast domain, you need to create VLANs, which is, you are virtually dividing the switch into different sub parts, right? So I think this is enough for VLAN. Thanks for listening. Hello friends, welcome in the class of basic STP. Here you can see we have two laptops, and we have three different switches I took. Okay, so what is the basically what I'm trying to do, I'll try to show you the by default configuration of STP, and then we will change the root bridge location. Okay, so first of all we have to go to the loopback 0 and assign an IP address, let's suppose, which is 10.1.1.1, and the subnet mask is default. We have to go to the laptop 1 and we have to align the IP address, let's suppose, which is 10.1.1.2, right? Now I'm trying to ping to my another laptop which is 10.1.1.1. I can. So here if you open all the switches, let's suppose this is switch 0, and you try to check show spanning tree VLAN 1, because by default all the ports are in VLAN 1. You can see that, okay, this is the root bridge information and this is my information, right? So I'm not root because these both information are not same. So if I go to the switch 1 and I'm trying to check here show spanning tree VLAN 1, you can check that here also the information is not same, or maybe it's same. We need to check. See, the information is same. That means switch 1 is by default the root bridge, right? Because see, you can see here it's showing that this bridge is the root. So that means if this bridge is the root, all the ports are in designated mode, right? These two ports are in designated mode. That means these ports should be the root port, right? Definitely. So here if you go to the switch 0 and you check the port number FA0/1, which is this port, this is the root port, right? And if you go to the switch 2 and try to check show spanning tree VLAN 1, see, this is the root port, which is FA0/1. Now one port is in the designated port and one port is the block port. Switch 0 port number, this one is in blocking state, right? So this is the by default configuration. Now let's suppose I want to make this switch 0 as a root bridge. So I have to type one command, which is spanning tree VLAN 1 root primary. This is a micro command. Once you type this command show spanning tree VLAN 1, you can check here. Now this bridge is the root. Once this bridge will be the root, see, the root bridge information, the root bridge MAC address and this particular switch MAC address will be the same, right? So now all the ports are in designated state. They are changing the states. It will take some time. You'll see. Now see. All the ports are in designated state. That means these ports are root ports and this is the blocking state now. So this is the by default behavior of STP. And by the help of basic command, which is spanning tree, VLAN, whatever VLAN you want to run, root primary, macro command, you can make a switch as a root bridge. So this is the basic information about the STP. Thanks. Hello friends, in this topology we are going to configure OSPF between two different areas. One is area 0 and one is area 1. R2 is a part of both the areas, area 0 and area 1, so it's an ABR. So what basic configuration I have did yet, I have just assigned the IP address to the interfaces and the loopback. You can check from here. It's 10.1.12.1, which is the interface, and the loopback. For R2 you can check the IP addresses I have assigned to the interfaces and one of the loopback, and for R3 also. Right, so I'll go to the R1 and configure this in area 0. So I have go to the interface and type the command IPOSPF1 area 0 and go to the loopback and type the command IPOSPF1 area 0. It's done. Go to R2 and go to the interface, which is a part of IPOSPF1 area 0, right? And loopback I'll assign it also in area 0, and the second interface is part of area 1, which is 1/0 IPOSPF1 area 1. Go to the R3 and then go to the interface and type the command IPOSPF1 area 1, right? And then go to the loopback interface and type the command IPOSPF1 area 1. Done. So this is the configuration which we can do, and now for verification purpose you can check that R2 is DR for this particular area, which is area 0, and R2 is a BDR for this particular area, because the router ID of R3 is greater than R2, so that is the reason. So we can check show IPOSPF neighbor. We can check R2 is DR for us, and for R2 this is the BDR and this is the DR. It is still in the convergence state because right now it's in the start state. Now it's full, so you can check C. So now a single router, which is R2, is a BDR for one area and DR for another area. This is the beauty of multi-area configuration. Now if you check the result, show IP route OSPF, right, you can see OIA. This means inter area. So we have received a route from R2. It's 3.3.3.3, right? So we can ping this, we can ping this, and we can ping this, right? Same for R3. Show IP route OSPF. We have inter area routes, right? We can ping it. Okay, so you can check show IP OSPF neighbor, show IP route OSPF, and third command is show IP OSPF database. This we will discuss in CCNP. Here you can see there are the LSA types, the information of LSA. This is the database, OSPF database table, right? So this is all about the multi-area OSPF configuration. Thanks for listening. Hello friends, in this topology we are going to configure OSPF in a single area, which is area 0. And what I did, I have created one loopbacks in all the routers and assign a IP address on the physical interface, which is fast Ethernet 0/0. So we can check this on a router R1 here. Type the command show IP interface brief. You can check that I have provided the IP address 10.1.1.1 and the loopback IP address is 1.1.1.1. If you go to R2, you can check by this command the IP address is 10.1.1.2 and the loopback IP address is 2.2.2.2. Go to R3 and check the same command show IP interface brief, right? So now I want to enable OSPF on R1, right? So we can do this by this way. We go to the interface and then type the command IP OSPF process ID is 1 and area is 0. By the help of this single command, your OSPF is enabled. Go to the loopback interface, IP OSPF1 area 0. Done. So this is the new way to configure the OSPF. You can go to the link level and enable the OSPF by this way. Same way, we can go to the R2 interface 0/0 and type command IP OSPF1 area 0. Then go to the loopback interface loopback 0 IP OSPF1 area 0. Correct? Then R3 also, we just go to the interface and type command IP OSPF1 area 0, and then we go to the loopback IP OSPF1 area 0, right? So this way, now you can see that we have neighborship with R2 and R3, and R3 is in, they are converging right now. So it will take some time. In the meanwhile, we can go to the R2, show IP OSPF neighbor, and R3, show IP OSPF neighbor. So it's in the process of convergence, right? Okay, now it's come up. Now here in this topology, you can see that R3 is the DR, because the router ID of R3 is, the higher one. It's 3.3.3.3, and R2 is the BDR, right? So if you go to R2 and type the command show IP OSPF neighbor, you can see here R3 is DR and R1 is DR other. Why R3 is DR? We can go and check. Let's suppose go to R3 and type the command show IP protocols. In this command you can see the router ID is 3.3.3.3. That is the reason this router is a DR. So if you go to R1 and type the command show IP route OSPF, you will get to know that you will learn the OSPF route. This is the route which you have learned, and the AD value of OSPF is 110, and this is the cost. Okay, right? Which we can find out 100 Mbps of bandwidth in Mbps. We can find out the metric. So you can go to R2 and type the command show IP OSPF, show IP route OSPF, right? R3, same command, right? And now you can ping. We have the reachability, right? So this is the basic example of OSPF configuration, right? You just no need to do anything, just go to the interface level and assign that particular interface into the OSPF. This is all about, right? So this is the basic configuration which we did about the OSPF in a single area. Thanks for listening. Good morning, friends. In this class I'll gonna configure EIGRP between two routers, router 1 and router 2. We have already assigned a subnet 10.1.12.0 between router 1 and 2, and I have created loopback 0 on both the routers. The IP address of loopback 0 on R1 is 1.1.1.1, and the IP address of loopback 0 on router 2 is 2.2.2.2. You can check this by the help of command show IP interface brief here on R1. Here you can check the loopback IP address is 1.1.1.1. And R2 also you will run the same command show IP interface brief, it's 2.2.2.2, right? Now what I'll do, I'll just assign the loopback addresses and the subnet in EIGRP so that we can ping, or we can provide the connectivity between the loopbacks. Okay, so for enabling the EIGRP, we have to go to global configuration mode and type router EIGRP and the autonomous system number. Let's suppose I took 1, right? And then we have to assign the network. First is 10.1.12.0 and the second one is 1.1.1.1, and then we have to type command no auto summary. If we will not type the command no auto summary, then when this network 1.1.1.1 goes to another bit boundary, it will automatically summarize. This is the by default behavior of EIGRP, right? So this is the configuration which I did under EIGRP process on R1, and on R2 also we have to run the same command, which is router eigrp1 note or summary network 10.1.12.0 network 2.2.2.2, right? So one thing you need to taken care that this autonomous system number should be same between the two device. What are the things we need to taken care? I'll let you know. First of all, we will check the results. So you can see here now the adjacency is up, IP eigrp adjacency is up now. So for checking, you have to type the command show IP route eigrp. Now you have a route for loopback 2.2.2.2. D means it's learned from eigrp, and this is the AD value of eigrp, and this is the metric, right? So now if you can ping 1.2.2.2.2, now I have reachability. Same thing I can check on R2 this, and when I ping I have reachability, right? So one more thing you can check here on R1. Once you type the command show IP protocols, here you can check lot of things. If two routers are neighbor, the two things should be same. One is eigrp autonomous system, which is 1, and second one is metric, right? Which is K1 means bandwidth, K3 means delay. This should be same, and the internal AD value is 90, right? So if you check the same thing on router 2, let's suppose this should be same, right? So this is the basic configuration of eigrp. If you want to run the authentication between two routers in eigrp, the command is this is the command. So once if you not no need to learn the entire command, you can use question mark and type the command. It is IP authentication mode eigrp1 MD5 IP authentication IP authentication. Then you can type the command mode eigrp1. Okay, MD5 we have already given this command. Then IP authentication key chain eigrp1. Then you need to give the keychain name. Let's suppose it's Amit, right? So you have to again create the keychain Amit key 1, and then key string Cisco. Once you did this, then the neighborship will break, because you have assigned the authentication on one interface on R1. So now if I'm running the route, I'm not getting anything, right? So for enabling the see here, if you see the result here, it says authentication failure. So for that I have to create a keychain here also, name Amit key 1 key string, it should be same, which is Cisco, right? And again I have to go to interface fast ethernet 0/0 IP authentication. Then I have to type mode, then eigrp1 MD5, then IP authentication mode eigrp1 keychain MD5. Okay, eigrp1, then okay, keychain eigrp1 Amit. So you can see if there's no need to learn the entire command, you can use question mark, because Cisco is very user friendly. So now you can check here the adjacencies came up, right? So now if you type the command under R1 show IP protocols, you can see that we are using the key. These are the metric values. Our hop count, maximum hop count is 100. These are the subnets which we advertise. By default eigrp is doing load balancing up to maximum 4 paths, right? So now if you check show IP route EIGRP, you have the route and you can ping, right? So show IP protocols, the basic command show IP route EIGRP is another command which you need to check. One more command, show IP EIGRP topology. Here you can check the topology table, right? So let's suppose if I'll go in an interface and I'll type the command I want to change the metric, so I can change from here also. Bandwidth 100, let's suppose, or either delay 100, let's suppose. So you can also manipulate the metric by the help of global configuration mode, and then go to the interface mode. You can assign the bandwidth and delay, right? So this is enough for CCNA EIGRP, how you can configure. And let me show you the commands which I have run. These are the commands, right? And if you run the command show run interface pass ethernet 0/0, you'll get to know that these are the commands for authentication, and I have configured the bandwidth and delay option also, right? So this is enough for CCNA EIGRP basic configuration. What are the things you need to understand before gonna configure EIGRP? You need to take care about the autonomous system number and the K values. Those should be same. If you're using bandwidth and delay for metric calculation on R1, you should use the bandwidth and delay for metric calculation on R2, right? So these two things need to be taken care for the EIGRP neighborship. Thanks.